Our topic today is design and detailing of retaining walls. The learning outcomes is, after this class, students will be able to understand the complete design and detailing of the different types of retaining walls. Retaining walls, we want to look now what is the retaining wall. Retaining walls are usually built to hold back mass soil. However, retaining walls can also be constructed for aesthetic landscaping purposes. Retaining wall is a wall built to retain a bank of earth due to change in gradient levels. You find that there are some places where the gradient of the land is too steep. So when there's this rains, you find that the water tends to wash away the soil, maybe to the sea, ocean, river, lakes, like that. So it is advised that you construct a retaining wall that can retain the soil from flowing down the land to the ocean or back to the river or lakes. So it is normally constructed at the bank of earth due to change in gradient. So this one reduces the gradient of the land that can retain some materials back the wall. So we have the height of the retaining wall, where we have ground level 1 and also we have the ground level 2 on the other side. Then we have the back soil, we have the pressure due to the back soil, we have the pressure due to self-weight, and also the resultant pressure due to the ground soil where the retaining wall is constructed. Now we look at the functions of retaining walls. The functions, there are three more important functions of the retaining wall. The first function is to resist the horizontal pressure exerted by the retaining materials on one side. Then 2 is to resist the hydrostatic pressure of any groundwater which may be present in the soil being retained. Then 3, to act as a supporting wall when required for bridge decks, floors, beams, etc. So those are the main functions of the retaining walls. And the other functions is maybe for aesthetic or landscaping purposes. Now we look at the design of a retaining wall. When designing a retaining wall, you have to consider some factors. 1, situation where the profile is. You find that there are some land which have a steep gradient. So you have to consider that. Then the height, what is the material to be retained and to what height. You find that maybe the material to be retained needs a higher height. So you have to consider that. Then the geology and nature of the rock. Some retaining wall can be constructed where we have some loose soil or hard soil or some rocky grounds. So that also you have to consider that factor. Then we also have the effect of water on the stability of the wall. Due to some gradient, you find that there's this flow of water that maybe can affect the stability of the wall. Then lastly, additional load as both dead and live on the wall. So you find that there's some load that can be embossed on the wall, where either dead or superimposed loads. So those are the factors to consider when designing the wall. Now we have classification of retaining wall. We have three major classification of retaining wall according to the drawings that we have, and also we have some photos that we'll have to see at the end of this lesson. So the first classification is gravity retaining wall. Then we have cantilever retaining wall and counterfort retaining wall. So we'll start with gravity retaining wall, which is normally made from masonry or plain concrete. So we have some retaining wall, mass retaining wall, which is made from bricks or mass concrete retaining wall. Let us start by looking at the gravity retaining wall. The gravity retaining wall is mostly made of masonry or plain concrete. So they are used for support of solids, e.g. soils and waste materials. They depend on their dead weight for strength and stability. They are sometimes referred to as mass retaining walls since they rely on their weight together with function on the side of the base to overcome the tendency to slide or overturn. They are limited to approximate height of 3 meters if inclined or 2 meters if the wall is vertical. Now, when you design this wall, you have to consider the height of the wall. It should not exceed 3 meters of the wall, because it only depends on the dead weight for strength. Over this height, the thickness of the wall has to comply with the safe height thickness ratio. So the gravity walls are designed so that the width of the wall is sufficient to distribute the resultant load of the wall and earth pressure to the soil below the wall base without under settlement. In design of this, a suitable width of the base can be taken as between 1/4 to 1/2 of the wall height. So the width of the top of the wall can be taken as 1/7 of the wall height. So gravity retaining walls require greater toe to provide sufficient base width so that no tension is developed at the base. Also, very heavy section of stem is required. So you can see we have the toe and the heel at the bottom, then the stem, which is now the wall, and the face, whereby now the wall is facing the side of the sea or the ocean, and the back, whereby we have the back soil. Then next, we can say that ground retaining walls can either be constructed of semi-engineering bricks blended in cement mortar of mix 1 to 3 or mass concrete, sometimes reinforcement welded mesh to prevent the problem of surface cracking. So that is all about the gravity retaining wall. Next we look at the the cantilever retaining walls. In cantilever retaining walls, we normally have the toe, the stem, and also it is normally reinforced. So it consists of cantilever beams, vertical stem, toe, and heel projection. In some cases, the toe projection may be missing. They are reinforced and work on principles of leverage, i.e. are designed to act as a lever against the supported ground and consequently allow high tensile forces acting on the retaining wall not passing through the middle third of the width of the base. Cantilever walls are required for retaining materials up to 7 meters high without being excessively thick. They are uneconomical for use below 2 meters, and the wall shape may vary to suit the loading and the material to be supported. So you find that the cantilever walling is normally reinforced through the stressed concrete and can also be used in liquid structures. For reinforced types, the main steel occurs from the tension face of the wall and are normally 0.15% of the cross-sectional area of the wall, normally placed on the opposite side to minimize shrinkage, which is generally common with in situ concrete. Such walls have economic height ranging between 1 to 2 meters, 1 to 6 meters, sorry. According to the drawing, you can see how the reinforcement is done in cantilever retaining walls, whereby you also have hardy core behind the whip or the hole, which is 75 millimeters diameter. This whip hole is used to drain water from the back soil back to maybe the other side or the ocean, sea, like that. So they normally place hardy core there to trap the soil that may be in that water. So we have some reinforcement bars in them and binders to beams. Then we look at counterfort retaining walls. As you can see the drawing, they are either constructed of reinforced or pre-stressed concrete. They are suitable for heights above 4.5 meters. Counterforts are rectangular beams positioned at suitable centers behind the stem and above the base. They enable base and stem to act as slabs spanning horizontally over or under the counterfort. The counterforts are normally designed at T-beams of timbering sections. So they are spaced at distances of 1/3 to 1/8 of the wall height. The base of the counterfort should be well tied into the base slab. So these beams, they normally have wall designed to act as a series of beams to resist soil pressure. So that is about the 3 classification of the drawings here to show how the retaining walls, different classification. One is the gravity retaining wall, then followed by the cantilever retaining wall, which is inverted T and L-shaped. Then we have the counterfort retaining wall, which has some reinforced beams in it. Now we look at the stability principles of retaining walls. Due to some pressures that are imposed on the retaining walls, this one tends to change the stability of the walls. So we are going to look at the types of pressures exerted on the wall. The first pressure is the earth pressure, which is exerted by the retaining materials on the wall. So we have 2 types of earth pressure. The first one is the active earth pressure. Now the active earth pressure, this is the pressure that exerts the force from the retained material. This pressure is increased by any surcharged or superimposed loadings. The pressure is applied for the full depth at the rear face of the wall but increases with depth. It is considered, however, that this can be repeated by force acting through the centroid of the force diagram. The design of retaining wall is considered from the point of failure, assuming that some movement has taken place. Another earth pressure is passive earth pressure, as we saw from the first drawing, which is denoted by capital P, small p. The passive earth pressure is similar to the active earth pressure. It is the force acting against the base of the wall by the lower level ground and is created by the tendency of the wall to slide. And that when the wall slides is due to the passive earth pressure that acts beneath the retaining wall and the active pressure that is acting above the wall due to some retained materials. Then we have the self-weight of the wall. This weight is the weight from the material of the wall. It acts vertically downwards through the center of gravity and produces the reaction at the base of the loaded soil. So this is now the self-weight of the material that maybe tends to make the wall bear in the ground by sinking in the ground due to the heavy material that was used to construct that retaining wall. Then we have frictional force. This is the force that acts on the base of the wall. Frictional force are created between the soil and wall construction which resists any tendency to slide. So as the drawing that I have here, you can see we have the sloping surface retained adding as a charge load. Then now we have the embossed load on the surface. Then we have the angle of repose of retained material and the active earth pressure. Then we have the mass of the wall acting downwards from the stem of the wall and also the passive earth pressure that is acting at the base of the wall. So this is the tendency of the wall to slide. So those are the forces or types of pressures that maybe can make the stability of the wall and make the. So we have the drawing here that shows the active earth pressure that may be exerted on the wall. Now we look at the factors affecting earth pressure. We have factors that can affect the earth pressure due to some soils that maybe are backfilled. So earth pressure depends on type of backfill, the height of the wall and the soil conditions. So there are several types of soil conditions. One, we have dry leveled backfill, which is maybe the dry soil that is backfilled, and we have also the moist leveled backfill. Maybe the soil is moist by maybe compacting it with some water. Then we have submerged leveled backfill, which is maybe submerged in the water, then the water is drained at some times. Then we have leveled backfill with uniform surcharge, which is normally a backfill to the level of the wall, and backfill with sloping surfaces that can affect the earth pressure. Now we have forces and loads on a retaining wall. We have overturning forces, bearing in the ground, forward sliding along the base, tension in the joints, and rotational slip. So these forces are the forces maybe that tends to bear to make the stability of the wall not. So we start by looking at overturning of the retaining wall. You find that the wall will have overturning by rotating about some point near the toe. If the overturning moment of the lateral force, which is anticlockwise, is greater than the stabilizing moment of the weight of the wall clockwise, then the wall overturns. So you find that there are two stabilizing forces that if one is greater than the other, you find that the wall overturns. Then we look at bearing on the ground. The bearing on the ground we have both downward weight of the wall and overturning moment, which will set up a bearing pressure between the base of the wall and the ground upon which it rests. So the maximum pressure will be at the top, which tends to sink on the ground. Failure will occur if the applied pressure exceeds the ultimate bearing capacity of the soil. Then next we look at the forward sliding along the base. Now this sliding normally occurs at the base of the retaining wall, where if the underside of the wall is smooth and traced on a smooth surface, the wall will slide along its sides of the toe and the heel. The wall only slides if the lateral thrust exceeds the frictional resistance developed along the base of the wall and the soils beneath. Now we look at the rotational, we look at the tension in joints. The tension in joints normally occurs in gravity retaining wall, which is made up of bricks or masonry, where we have joints between the bricks. So in this case, compressive stresses will be set up due to the weight of the wall. At the same time, there will be bending stresses which are tensile in nature due to the retaining material. If the bending stresses exceeds the compressive stresses, the net tensile stresses will result in the wall just above the heel, causing tension. In mason wall, these tensile stresses may have the effect of opening the joints. So that is about tension in joints. Lastly, we have rotational slip. This one is due to the weight of the wall, self-weight, and the weight of the retained material. Now the wall, together with larger amount of retained materials, will rotate about the same center if the amount of the weight of the wall in the soil mass exceeds the amount of the shearing resistance developed along the circular arc. So you find that the wall tends to rotate due to the self-weight and the weight of. Now we have factors affecting the stability of a retaining wall. We have factors that can affect the stability of the retaining wall. The first factor is the angle of repose. The angle of repose of the retained material. This will indicate the weight of material above the angle of repose that the wall must retain. Then we have the self-weight of the material. The self-weight of the material usually acts vertically down through the center of gravity, and as a result of this, the reaction is produced at the base of the loaded soil. Thirdly, we have the resultant thrust on the wall. This is from the material weight, which also depends upon the material density. Then we have the thrust of the liquid or even groundwater. The problem of groundwater is solved by incorporating good drainage by employing whip hole and granularly backfill. So the thrust of the liquid or groundwater can be solved by making a whip hole in the retaining wall to retain the water from the soils that is retained. Then thrust of insurcharged loading, the vertical loading of any structure located on top of the wall, like external loading, the function between the retained material and the wall face, and function between the natural and artificial foundations. Here is the second photo, also shows how the retaining wall is constructed to retain some materials from the earth, not to be carried away by the water to the ocean, the sea, or maybe the lakes, rivers, so forth. So you can see this retaining wall is made up of maybe masonry stones, and it is normally you can see it is maybe for landscaping purposes or aesthetic purposes. The third picture is of the counterfort retaining wall. As you can see, the way it is constructed, it has some reinforcement in it, and the wall also have the beams to support the wall. This is also another type of retaining wall, which is used to retain some soil from the back of the wall, not to be carried away due to a steep gradient of the soil. This one is also another type of retaining wall, which is made for also retaining some soils due to the steep gradient of the soil or the landscape of so these are the photos to show how retaining walls are constructed for different